Artificial intelligence. When we talk about artificial intelligence, it's such a broad topic that it's important to say it's a field of computer science. So it's not just some GPT chat or some Claude or any other thing like that. There are three main things, as Roma said, the sacred or something, God, the Trinity, and so on. Here, we have to predict, optimize, and generate judgments. There are three main parameters that artificial intelligence deals with. It's not about generating pictures or making some music or just chatting while drunk. That's not a core function. But what does it do? It is capable of analyzing data, identifying patterns, and improving its performance over time. That is, it is capable because it has what is called reasoning, some kind of thinking. From the perspective of artificial intelligence, it is capable of improving its own judgments. It can predict all the models that came before. We already know about artificial when we found out when GPT and similar services appeared, but before that there were many different models and they were used by a lot of companies, and that's a fact. But we just hadn't heard about them because there was no hype. Well, that's always the case. So all those models were mainly engaged in forecasting based on historical data. In banks, in various insurance companies, only large enterprises. They could afford it. It can process a large volume of information to gain insights and make predictions. It can predict better than a human because it has greater capacity in certain thinking patterns that people don't have. Based on what it has forecasted and its self-learning ability, it is capable of optimization. That is, it can see what you have if you set the task correctly and improve it based on all this other data. And only lastly, there is generation. This is when it generates text, videos, basically anything. Any text, all our conversations with it are its output. It's a feature, but in reality, this is not its main function from the perspective of artificial intelligence as a field of computer science. This is a kind of foundation that needs to be understood. We can not only have conversations, but also create chatbots. What is it? Large language models? There is a lot of information about how this works. We won't go into the details. A large language model is a thing that also involves training, tokenization, prediction, and generation. It's the same principle, but it's trained on a huge amount of data, an enormous amount. It's a very complex system. Its architecture is usually unknown. It's a black box. Well, if we talk about all the ones listed here, and these aren't even the latest, this is already an old presentation. We don't fully know how it works inside. We can't predict it. It's not predictable or clear to us, and so on. And it's a system that has been trained on enormous volumes of data. And in principle, no one specifically verifies these volumes of data. We had Piotr, I think, the guy who spoke in Polish. He was saying that GPT is just a toy, a plaything. Basically, that's true. Why? Because what do these models actually do? They learn from all the available data. Whatever's out there on the internet. Any kind of junk that gets thrown onto the internet, it reads it, basically classifies it somehow, and it all depends on what you want, how you ask, and whether you can sort things out. There's a big problem in this, but also an opportunity, depending on who you ask. There are small ones, there are small language models. Not all of them are large, there are different models. Some are used for specific tasks, and they're not always ChatGPT. Like Gemini, the one from Google. Google, for example, has been using such models for many years for its own search and ad optimization, and there have always been non-generative models there. And for specific tasks of specific companies, it's cheaper to use these kinds of small models that are tailored for particular tasks. Right now, everyone is building everything based on large language models because they're easier to configure. But often, when someone comes and says they need their own model, I say, would you send a package? Don't buy Nova Posta, let's look for something else. A local solution to start with. Non-generative models. What is an RX system? These are important terms. Retrieval Augmented Generation. There's a database of some data, some knowledge. You formulate a question. So, context from your knowledge base is taken, the question is added to it, and then it's sent to the language model. The language model receives the context from what you have, just like I did right now before your eyes. It gets the context and provides an answer according to this context, which also takes into account your knowledge base. So it takes the question, retrieves information, generates, and gives an answer. That's what rack systems are. Most of these similar architectures that I showed you are built on the basis of rack systems. What is an AI agent? There is an LLM, which is like the brain, where this thinking happens, conditional technical thinking. There is this context window. Well, in short, there are a lot of things there. And there is a code algorithm that does certain work by communicating with the LLM. And that's the AI agent, meaning it's a certain, the code can be different, it can have a different architecture, but the point is that it's a specific code that performs a certain task and constantly asks the LLM something. And based on that, it responds and provides a solution. Imagine that the LLM is like a foreman who sits and calculates estimates, makes decisions at the construction site, and the agent is some guy who lays tiles. He just keeps laying them and asks, am I laying them correctly? Fix this part here. That's how agents work. Agents can perform any functions. Let's say yes, we can hope that they will perform some functions that we need. But as the classic said, things are not so straightforward. And the last story is about what the knowledge game is. The main issue here is that Roma mentioned the context window. We can't, if we have, say, 100 documents in the company, okay? If we have 10,000 documents, I've had several projects, unfinished ones, I was just testing them like that, and it would, just like now in the first case, give me something wrong, make a mistake. In short, when there are a lot of documents, the context starts to overlap or become similar according to these semantic features. Do you understand what I'm saying? And then it wouldn't fit into the context window. They use all sorts of stuff there, like summarization, compressing it, sending it back, and so on. And that's what the topic of knowledge graphs is for. A knowledge graph is a kind of structure, a certain accepted one. You see, Elon Musk founded Tesla, not just Musk Tesla. That is basically, any theory, any knowledge can be structured by concepts. For example, name me any theory, just something basic. The Earth is round. The Earth is round, yes. So what do we have about the Earth is round? There is the Earth, there is an orbit, there is the universe, there are other planets. In short, the Earth is round is a story about the existence of around 20 terms, some entities. They are all causally connected to each other. The Earth is spherical in shape, as we all know. And it is certainly not the Moon, not Mars, and other celestial bodies. And based on this, a structure of knowledge is formed. And then, so to speak, the AI understands where to get the context from. That is, when it encounters a specific question, it goes directly to the pattern where that knowledge is stored. This is the game of knowledge.